Hello, I will use this video to go over assignment 3, motion, speed, and velocity and acceleration, and which basically summarize what we have learned in class for this week. Alright, I will not go every details, but I'll leave some work for you. And then, so there are 3 questions. The first question, you will start from this link. If you double click this, it will bring you to this app. Okay, and basically, if you can see, start from 1 meter, and also you can adjust this. Then you zoom in or you can zoom out. You zoom in, for example, smaller, 10 to the negative 1, and it's called a decimeter. And you see what are in the decimeter is like the palm and the egg, or 10 centimeters, so that's called a decimeter. And then if you can zoom in further and down, so you bring further down, you can 10 to the negative, and that's the centimeter. So centimeter is like 1/100th of a meter. So then you can adjust. So you can also go big on the other side, zoom out, okay, and then 10 meter, 10 to the first. Okay, what's a 10 meter? It's like the height of giraffe, some elephants, so dinosaurs, satellite, and then of course I would want you to put something in 10 meter, but then not just you play with this, and then what do you do? For example, start in the middle, and these prefixes, and these are the prefix, and these are the symbol, and these are the meaning, and in the middle is meter. Okay, mathematically we describe this with powers of 10. In the middle, 10 to the 0. And what is 10 to the 0? Anything to the 0 mathematically is 1. So we start from here. Okay, what is measured in the meter? Actually, I want you to put here. For example, how long is a meter? I would say, well, something like a guitar, right? Yeah, something like a guitar. And so, right, so you can write by hand, or guitar, or desk height, desk, or whatever, or your arm distance. Put a couple of things in here. So you're done with what's inside. How long is a meter? So a meter, I shouldn't stack about this long, that meter stick. Okay, or from my arm to my from my chest to the fingertip, that's about it. So things of that size. And then you move on to, I suggest on either way. So positive 10 times is called decameter, or 10 to the first. And then you bring back to here, or you don't have to, okay? You don't have to with this. So 10 to the first, so the decameter. So you would say elephant, giraffe, and things. So, okay, elephant, giraffe, or size of your room, or my room is 10 meters, and so on. So if you go down that way, 10 to the negative 1, and I would say is decameter. A decimeter is like okay, tissue box. Okay, box. Well, one of the tissue box, and my cell phone. So that's the size of a decimeter. Things like that. Yeah, you don't really have to rely on. In fact, I prefer you don't use this app. But of course, with this, of course, when the thing become large, you do have to rely on this. So the terameter, and go both ways, fill this up. So for example, if you say millimeter is this, what's in the millimeter size, then you 10 to the negative size, you will say tip of a pen, or head of ends. Okay, head of ends, that's in millimeters, and the micrometer, something like cell, and those of you who are in biology, cell or some bacteria and things. But if you don't know, go here and go to micrometer 10 to the negative 6. You just zoom in 10 to the negative 6. So then you will see what's in the micrometer 10 to the negative 6. So zoom in. So think about it's ultraviolet light, mini-virus, actually coronavirus, UV light, bacterial, or something like that in micrometers. Okay, large virus. Okay, virus is smaller than micrometer. Like virus is smaller than and then of course if you could, I challenge you to what coronavirus in which size, in which bracket. So I think you get an idea what I want you to do. Okay, nanometer, terabytes, so what things are inside? Fill this one. So that's question number 1. Basically get familiar with the prefixes, what actually they mean in real world, in length at least. All right, the second question is they simply calculate the speed and the distance. In fact, we have to go over this in the class. Since a few of you haven't turned in your homework yet, so I use this video to help you work out. So, and the question, actually there are 2 parts of the question. And then just give you what is the speed of each hour in this trip. For example, first hour, so then you should write down here, so put another table, or hour 1. Okay, say hour 1. Okay, and then the speed is always distance divided by time. So you went 50 mile in 1 hour. So it means that actually 50 mile per hour. Okay, hour 2. So go from 50 to 50 starting position. So actually the distance is 0. So distance equals 0, hour 2. So hour 2. Okay, hour 2. The distance, the second hour, you go from here to here. So second hour is distance. So then it will be, so I'm typing here if the video is not strong enough. So hour 2, the second hour, go from this part to that part. So then second hour, and then go from 50 to 50. So the distance is 0. So distance equals, it didn't go, 50 minus 50, which is 0, and it's still hour. So, and then the second, so 0 divided by hour, 1 hour, and actually speed is actually 0. And the third hour, so I do 3, you do the last 3, okay? And the third hour, what's the speed? So then the third hour, it's from hour 3 to 4. Actually, the distance it travels, it actually goes from 50 to 85. So later one, 85 minus 50, so it travels 35 miles. 35 miles, and it's still 1 hour. So this is like the speed is, therefore speed is 35 miles per hour, and so on. And so on, you do the rest. Okay, and here's another question, which is very important. So this is the trip to Washington, D.C. It's kind of from here. Okay, what is the average speed of the entire trip? So the average speed of the entire trip, you basically get the whole distance. Okay, you go vertically. So in fact, from here, low. Okay, the entire trip actually goes from here, all the way from here, all the way to 190. So here is 190. So 190. Or you can look from the chart on the left, and basically contain the same information. So from 0 to 190. So it's total distance, so average, speed, average, that's A, average. Okay, and total distance is 190. Okay, what is the overall distance? So it takes 1 hour, 2 hours, all the way 6 hours. So 190 divided by 6, anyone tell me? Okay, I'm pressing calculator over here. Okay, so 190 divided by 6, 90 divided by 6, I get 31.6. So it's 31.66 bar, which means 67. So then don't forget the units. So it's a mile per hour. Okay, even though sometimes you drive very fast, but overall, because they stopped twice. So this flat area in the chart is when they stop here. So that's when they stop. Okay, and it will stop. So the time keep going, but the distance is not rising. Okay, and here, so it stopped here. Okay, because time keep going horizontally, but the time, the distance is not going. So basically, this is like they are in restaurant. So this. Then anything that goes up has a slope. That means they're going. The higher the slope, the faster they go. So that's the second question. Hopefully you finish everything. So remember, there are 2 questions. I would say this first question is part A, the second question is part B. So write nicely, submit today. Okay, the last question. Actually, I only have 3. This should be number 3. Okay, not number 4. Okay, the last question. Company graph. This is a graph Mary's distance from home A to F to work, and this is his. I will show you different kind of travel graph, as same as above, but this was a different story. Distance from home, and say goes, and for some time she realized that he forgot something. She returned home, and then slowly continue go. In the middle, he take a break, and then keep going. So that's the travel graph. So, okay, Mary left her break, had to return, start driving, and which point represent she returned back? She decided to return back is right here. Otherwise, he would have keep going up. But then see, the slope is negative. It's going from B to C. This is distance is going backwards. Okay, B to C. So the point is B. She decided to turn back. And actually, how long does it take to go back? It's from here to here. Even though I didn't ask you a question, later I may ask you a question. How long does it take her to come back home? And then take 5 minutes from B to C, so 0 home again. Okay, and so Mary also had to wait at here, so that's B. The answer is B. Okay, while D is at home. Home is at D when it comes to D point. So Mary also had to wait at the railroad track for a train to pass. How long did she wait? Okay, when she waits, her distance is never go up. So therefore, and you look for some area that's flat. So here, it didn't go further. Did neither go up nor go down, so the distance not rising, but the times keep going. So time keep going for 5 minutes before he start driving again. So that's take how long did he wait? So the answer is 5 minutes. Okay, so how far is it from home to her workplace? How far it is? So C, the question C. So then that will be simple. So vertically at 40 minutes, and then go all the way to the F points. So that's about 20 miles exactly. So it's 20 miles. So 20 miles go from here and up. Okay, and the last question, how many minutes does the entire trip take? All right, so then you should also vertically 20 miles at F points. Okay, so entire trip will take from here 0 all the way to 40. So that's entire trip. So go out, forgot the briefcase, go back. So go out, forgot briefcase, go back home, slowly driving, and wait at the station, railroad station, for 5 minutes. And then she realized she has to catch up, so she goes faster all the way to the work. So when the slope is higher, she goes faster. So that answer is 40 minutes. Hope this is helpful. Okay, you got to turn in the assignment today. So this is the assignment. So don't look at my answer and just do your own answer. Okay, bye bye for now. Have a good one.